Hello viewers, welcome to the lecture. Today we are going to see about basic civil and mechanical engineering, in that unit number 5, refrigeration and air conditioning system. So in today's lecture we are going to discuss about the refrigeration and air conditioning. This is in continuation with the part 1 of this lecture series. So there are some confusions among the public to understand about the terminologies related to the refrigeration and air conditioning. So the first is about the what is the what matters most, right? So here the poor system design, right? It is because if the system is designed in such a way that if it is not efficient and if it is consuming more power, so what happens is automatically the energy consumption goes high irrespective of the performance, right? So nowadays the refrigerators and air conditioners are provided with star ratings, energy star ratings. You can see in the product that 3-star rating, 5-star rating, etc. So this is what the main thing. So the design of the system should be efficient in such a way it should meet out the minimum energy consumption. The next is about the depending upon the heating, ventilation, and air conditioning. That is simply called as HVAC, HVAC, right? So it depends upon the precise language to diagnose the faults, so that it can solutions can be implemented quickly in order to save the time. And the next thing is about providing the clear definitions on the things, right? The consumer to make informed about the investments to ask, and they should ask the right questions to understand about the system and its performance. So one of the factor is about the energy star rating, as I discussed previously. So in this stage, you can see here it is the ideate stage. So the system can be categorized into different things. The first thing is about the single stage system. So it consists of only the simple on-off operation, right? So either full power or it completely goes off. So this system is less efficient with noticeable temperature that swings and frequent cycling. So this is a normal system. The second system is the two-stage system. So you can see here in two-stage system, it operates at low capacity, typically of 65 percentage most of the time. It ramps to high capacity on during peak demand. So it delivers a consistent comfort with the significant energy savings. And the last design is the variable speed system. So you can see in variable speed system, multi-speed settings can be enabled in order to control the temperature, humidity, and also to adjust the output continuously to match according to the actual load requirements. So these are the different system designs. So you can see the refrigeration cycle and staging, right? So the refrigerator you can see here, compressor, condenser, evaporator, and the expansion device. So these are the major things or components that are available in the refrigeration. So this cycle is a continuous loop where the refrigerant transforms between liquid and gaseous states. So it moves from heat from the outside to the heat from inside to the outside. So in this slide, you can see the design for user comfort and efficiency. So this slide describes how understanding terminology can inspire a better HVAC system or solution. The first is about the smart components. Smart components in the sense adaptive compressors responding to the current load. So if the load is high, the compressor should continuously run. If the load is not high, the compressor can be operated likewise. For an example, if the hall consists of some uh, one or two members, the refrigeration, the running of the compressor or the that is creating the refrigeration effect can be minimal. Imagine if the hall has some 100 or 200 members, so there the temperature inside the room increases. So accordingly, the compressor should be operated. Then the electronic expansion valves with precise control. Then the low GWP refrigerants. Yes, because the components should be smart enough to operate according to the conditions. Then the next is the user-centered design. So to install a install an AZ, you can see here. So it should be smart enough, and the user can be capable of operating the device according to the requirements. That is called user-centered design. And the last one is about the efficient goals. Yes, obviously, the reduced energy consumption, the lower utility bills, and minimized environmental impact. Because nowadays, the government enables us to use solars. So these solars can be capable of generating electricity, so that it can be used for domestic purpose, not only depending upon the electric current. So the remaining part we will see in the next lecture. Thank you.